Welcome back. Finishing up our trinucleotide question. And then we'll do a brief introduction to one of the lipid functional groups in chapter 26. We're going to do hydrolysis reactions and get all of our bases back in their original forms down here. And you are allowed to use short forms if you carefully circle things. And we'll circle things. We'll call one of them R1 and R2, everything up to the N. And R3. They were hard enough to draw the first time, right? These things will have their protons always, no matter what the pH is. One of the products will be R1 attached to H. And yes, your short form shows that where the circle ends is where you will attach something. So we'll have an H with R2 and an H with R3. R3. Pink. And then we have 5 phosphates. Only the first H is missing at pH 6.5. The numbers tell us that. 6.5 is below the pKa for the second H, and of course for the third H. But 6.5 is above the first pKa, so it loses its H based on this statement here. pH of the environment is above the pKa for an acid, the 2.1 acid. It's below the pKa2 acid, which is this one or this one, and it's below the 12.7, which is this one or this one, you decide. So we have 8 of our 11 molecules, and we have 2 deoxyriboses. And hydrolysis is typically going to make a mixture of alpha and beta hemiacetals. And you're going to get one straight up ribose from the bottom part. Mixture of alpha and beta. You can use the squiggle. And that's the end of that question. So you'll see it's the same every semester. I mean, these are points. I mean, just follow these steps. You'll be getting these points, right? And finishing up with just a little bit of chapter 26, because that's all we have time for. We've got like 10 minutes. Triglycerides are a type of lipid. That's your doctor checks you for triglycerides when you show up at the doctor's office. And its name comes from glycer in the middle being derived from glycerol. Old school name for glycerol is glycerin. You can actually buy suppositories of glycerin. And I don't know if you want to know what they would be used for, but let's just say you better be close to the bathroom after you take them. And that there is glycerol. That is the backbone of both triglycerides and phosphodieesters. We'll do those next time. So glycerol is, its UPAC name would be 1, 2, 3 propane triol. And I'm never going to give you the structure of glycerol, but you're going to have to use it many times. So just it's the 3-carbon trialcohol, has an OH on each of the carbons. Not hard to remember glycerol. And after you do hydrolysis reactions, you'll always make the glycerol back. Yep, I love doing the hydrolysis questions. It kind of puts a neat little ribbon on all of the things we've learned in 2 semesters. All right, triglycerides, we're going to make esters. You didn't know that, did you? Triglycerides are triesters of glycerol. And aren't esters made from alcohols, which glycerol has, and carboxylic acids? Indeed. Here's your carboxylic acids. Do you have to memorize those 3 carboxylic acids? Oh, please don't. We have to go to our useful handout on page 1 and find oleic, linoleic, and EPA. I'm just going to go grab them all. Oleic, linoleic, and EPA. Oleic, linoleic. Oh, linoleic is different than linolenic and EPA. Should I just try to grab them all? See if it takes up a lot of space. There we go. The most abundant fatty acids. Okay, go on our last page here. Waiting. Yeah. I think it's clear enough over there, huh? Good. And you're not allowed to use parentheses on these questions. It's not going to say it here, but I want to see all the carbons and stick figures, please. So even though it's not said here, I want stick figures. So how do you make esters? Well, you take your alcohol and don't draw OH. Remember, they're condensation reactions. Alcohol loses H, carboxylic acid loses OH from the carbonyl. Oleic acid right here. The carbonyl's over here, people. Don't just copy what you see. That makes me really sad. A student's going to copy CH3, CH2 5 times. No, it's whatever times. Don't, no. The carbonyl's attached. There. Okay, so you keep the carbonyl. You lose the OH, so one of the O's is still there, carbonyl. Then you're going to draw me 7 CH2s, then a cis double bond. If you draw a trans double bond, you're telling me you know nothing about natural fatty acids all being cis. Okay, did I say that clear enough? All alkenes must be cis. Trans is not natural. You've heard all this bugaboo about trans fats. Yeah, they are bad for you. It's because they're not natural. Your body doesn't know what to do with them. So 7 CH2s after the carbonyl. Oh, we're under I got a deadline now. Carbonyl. CH2, 1, 2, 3, 4, 5, 6, 7. Goes to a cis double bond. I like to do them this way. There's your cis double bond. Then CH2 7 more times. 1, 2, 3, 4, 5, 6, 7. Where did I get that information from? CH2 7 more times, and then a CH3. CH3. I got my CH2s there. Should have 18 carbons. 1, 3, 5, 7, 9, 10, 11, 13, 15, 17, 18. Nice. Now we got to put linoleic. Carbonyl, then 7 CH2s again. One, 2, 3, 4, 5, 6, 7. Then it goes to a C double C that's cis. Goes to another CH2. That's the parenthesis. The parenthesis finished right here. Let me prove it. Linoleic. Parenthesis started with C double C, ended with a CH2. There. Next parenthesis. C ends with a CH2. There's the parentheses. Then 3 CH2s that are new and a CH3. 3 CH2s that are new. 1, 2, 3, and a CH3. And if you count up those in a row, it should be 18 again. 3, 5, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good. If you have the wrong number of carbons, you're in trouble. If you have an odd number of carbons in any chain, that's not natural. You'll learn why next lecture. EPA is down here. Just 2 CH2s, then a third CH2, then double bond, and we're doing that 5 times. 2 CH2s after the carbonyl, of course. CH2 once, CH2 twice. Third CH2 is part of the parenthesis. Then, and do that again. And do that again. And do that again. And do that again. 5 double bonds. CH2 once, CH2 twice. That was the start of the first parenthesis. This was the start of the second parenthesis. Third, fourth, fifth, end of the fifth parenthesis. EPA ends with CH2, CH3. Oh, it's an omega-3. That's omega, the end. Omega 1, 2, 3. 3 from the end is an omega-3. Those are very healthy. This one's an omega-6. 1, 2, 3, 4, 5, 6. Also healthy. Not quite as healthy as omega-3, but good. And omega-9, they're pretty good. But the omega-3s are nice. That's what omega means. End. Omega. Alpha, omega. Those are your first and last letters of the alphabet. And we're really under the gun. Why is this an oil and not a fat? Cis double bonds have kinky shapes. Cis alkenes are kinky. Not in predilections, but in their shape, people. Kinky, so London lower. How's that? They can't get on top of each other. So the London forces are down. So they're not solids, they're liquids. That's the only difference between an oil and a fat. Did you know? Oils are liquids. Oily. Quickly, hydrolysis gives you your, I got the glycerol already. I'm not going to draw it again. Hydroxide is a base. Quick. We got to do our R's. Ooh. R1. Should use a different color. Out of time. That's okay. Can I buy an extra second or 2? It's worth it. This part of the course is fun, isn't it? And then yellow. We never use yellow. Let's use it. So up to the carbonyl. So you're going to have R prime attached to O minus. You're going to have R double prime attached to O minus. These are all fatty acid carboxylates, aren't they? And yellow R triple prime O minus. Soaps. And this one here, you'll read about it on every exam answer key. It's useful in moisturizing creams and found in soaps. Humectants keep humidity in. That's where the name comes from. They keep your hands moist. And I think I got the answers down for this question up here. You know what soaps are good for, right? And humectants, good for keeping your hands moist. And that's it for today's lecture. We'll finish lipids next lecture, and then everything else that we'll lecture after, and we're not even going to rush because we're almost done. And if you haven't done so already, 2 very important emails were sent earlier today. You need to read them. And I will see you when I see you.